One of the most powerful tricks for data scientists working in R or any other programming language is the use of regular expressions. Mastering regular expressions is a great way to level up your programming skills, so in this video we're going to learn how to work with regular expressions in R. First we'll learn how to construct regular expressions, and then we'll learn how to work with regular expressions using the popular Stringr package. So what is a regular expression? If you don't know, a regular expression, or regex for short, is a concept that exists in many programming languages. A regex is a sequence of characters, which can be letters, numbers, or punctuation, that describes a certain pattern found in a text. Regular expressions are useful if we have a string, or multiple strings, or a block of text that we want to manipulate in a certain way. Maybe we want to find, or count, or remove, or replace, or in some way modify parts of the text that are associated with a certain pattern. The most convenient way of working with regular expressions in R is using a package called Stringr. Here are a list of these Stringr functions, which you can download the cheat sheet from the Stringr GitHub, which I'll link below. You'll notice that all of the functions within the Stringr package look very similar. They all start with the letters str, followed by an underscore, and end in an intuitive name that describes their function. Before we start coding, let's take some simple examples. Let's say we want to find all instances of the letter A and remove them from a block of text. If the text on this slide were assigned to a variable in R, and we use the Stringr function strViewAllA, Stringr would show us all instances of A like this. If we instead used strRemoveAll, all instances of the letter A would be removed. If we wrote strReplaceAll, A-O, then all instances of the letter A would be replaced by the letter O, just like this. Of course, viewing, removing, or replacing simple strings like this using the Stringr package doesn't require much actual knowledge of regular expressions, but note that regular expressions will come in more useful within the Stringr package the moment you start to do anything a little bit more complex. Okay, so now let's open up RStudio and start off by loading the Stringr package, assuming you already have it installed. Before we explore the different functions within the Stringr package, let's look at some examples of how to construct regular expressions. So for these examples, we're going to make use of a function from the Stringr package called strView, which we've already come across. The strView function simply allows you to view the occurrences of a given expression within a given string. So let's use as our string, regular expressions are awesome. I use about 100 of them each day, 200 on Mondays. This sentence is a nice example because it contains a mixture of character and numeric expressions, both upper and lowercase letters, as well as punctuation, just like any good strong computer password. Let's assign our string to the variable x. To show how the simplest example of that strView does, let's write strView, input our string x, and a word. Let's just take the word awesome. And so if we run this code, we see that it outputs our string with the match highlighted. Now let's construct some more complex regular expressions and use our string with strView to show how they work. Remember that the Stringr package contains many more functions for operating on regular expressions in more useful ways, such as removing, replacing, detecting, and counting, which we'll look into in the second part of this video. But for now we'll stick with strView for the purpose of illustrating how regex are constructed. The following examples of regular expressions can be used to match all instances of a particular type of character or word within a string. For example, all digits, all characters, all upper or lowercase characters, all punctuation, or all white spaces. Let's check how this works. Let's first try strView x digit. But if we want to detect all digits in the string, we can instead use strView all. Let's try the same with alpha. This should detect all letters. If we try lower, we will detect all lowercase letters. Upper will detect all uppercase letters. Punct will detect all elements of punctuation. Blank will detect all blank spaces. Note that the full stop or period picks up every character except new lines. You might think this isn't so useful on its own, but you'll see that this dot becomes useful when we start to combine it with other elements. For example, if we use the regular expression a.e, we would detect any instance where an A and an E are found surrounded by any other character. So in this case, the word R, as well as the aw in awesome, are both detected. So the full stop acts kind of like a wildcard. It's important to know when constructing regular expressions that there are certain special characters that we need to what we call escape. Let's take the full stop as an example. We saw that the full stop in a regular expression will detect any character, kind of like a wildcard. But what if you actually want to detect the dot itself? To specify that we're actually interested in the dot and not in using it as a wildcard, we need to preface the dot with a backslash, like this. This is what we call escaping the character. There are several other characters which need to be escaped in this way, because they have other special functions. For example, the question mark and quotes. Let's say we want a regular expression that detects all vowels. To detect any of a set of characters like this, we can use the square brackets. If we place all of the vowels A, E, I, O, U, or any other character that we're interested in, within the square brackets, any of them will be detected. Note that if we tried this without square brackets, it wouldn't work because the exact string A, E, I, O, U is not actually present anywhere in our sentence. So now we've detected all vowels. Similarly, if we wanted to detect all consonants, we could put all consonants inside the brackets, but it would take quite a while to write all of the consonants. So what can we do instead? Well, we could tell R that we're interested in everything that's not a vowel. If we add the caret symbol inside the square brackets, this is basically telling R that we want to detect anything except for these characters. Does this work? You'll quickly notice that this trick isn't quite enough to detect only consonants, because if we exclude vowels, we're of course still going to detect all of the digits, all of the punctuation, and also the white spaces in our expression. So let's try to combine some regular expressions in order that we can detect only the consonants in the sentence. If we add the expression for digits, white space, and punctuation inside these square brackets, we should no longer be detecting anything in the sentence except consonants. This time it works. Okay, so let's say we're interested in a certain range of letters. For example, maybe we're interested in all letters between A and E, i.e., so A, B, C, D, E. To do this, we can use the hyphen to specify a range, so either a range of letters or a range of numbers. For example, every letter between A and E, or every number between, let's say, 0 and 1. We can also use what we call quantifiers in regular expressions to specify how many instances of a character or expression should be matched. For example, adding a question mark, we can detect any instance of either a 0 or 1 matches. Adding an asterisk will detect any instance of 0 or more matches. A plus will detect any instance of 1 or more. We can also even be more specific, saying that we want to detect exactly n number, or n or more, or between n and m instances. Let's try some examples. For this, let's create a vector of numbers 1, 10, 100, 1000, 10,000. Note that we can use strview on vectors just like we did on single strings. So strview 10 will detect the 10 at the beginning of these 4 digits. If we use the question mark quantifier, we tell R to detect any instance of the 1 followed by 0 or 1 zeros. So now the first one is also detected, since it's a 1 followed by 0 zeros. If we use the star quantifier, we detect anywhere where a 1 is followed by 0 or more zeros, so that detects everything. If we use the plus quantifier, we detect anything where 1 is followed by 1 or more zeros, which detects everything except the first one. If we specify in curly brackets that we want to detect only one zero, we will detect the 10 at the start of the last 4 digits, but not the first one. See how this changes when we specify 2, 3, and so on. Alright, so the last regex trick we're going to look at is anchors. Anchors allow us to detect patterns that occur specifically at the start of a string or at the end of a string. If we precede a regular expression with the correct symbol, we basically tell R that we only want to detect this if it occurs at the start of a string. Alternatively, if we add the dollar symbol to the end of our regular expression, we're telling R that we only want to detect it if it occurs at the end of a string. For example, let's create another string, rata-rata-ta. If we want to view the instances of ra, we find that there are 2. But if we introduce the correct symbol, we'll only detect the first instance, the one that forms the beginning of the string. Similarly, for ta, we find that there are 3 instances. But if we introduce the dollar sign, we will only detect the last instance of ta, the one that forms the end of the string. If we added the correct symbol to ta, we won't detect anything, because there is no ta at the beginning of the string. For the rest of this tutorial, we're going to look at a few more of the functions within the Stringr package beyond strview. Let's keep using the sentence that we created earlier. The remove function can be used to remove parts of a string that match a particular pattern. Let's remove all vowels. Let's demonstrate this again by removing all capital letters. Next, let's use the replace function to replace all vowels in the string with the letter X. strreplace X, X. Let's use the strcount function to count how many letter T's are in the string. For this we write strcount X, T. Let's use the count function again to count how many digits are in the string. strcount X, digit. Let's convert the whole string to uppercase letters using the str2upper function. Similarly, we can convert the whole string to lowercase using str2lower. If we want to see if a particular string is contained within our larger string, we can use the strdetect function. Let's use the detect function to see if the string contains the word hello. Here the output false tells us that it does not. Let's see if it contains the word Monday. strdetect X, Monday, outputs true, telling us that this word is contained within our string. Let's use the locate function, strlocate, to find at which position in the string is a particular character contained. Let's check for the exclamation point, and remember that this is one of the characters we need to escape by preceding it with backslashes. strlocate tells us that the exclamation point is located at position 32. It both starts and ends at position 32. We can use the sub function, strsub, to see if this is correct. strsub x32 returns the exclamation point, telling us that this point is at position 32. Let's use the strsub function again to see what characters are at another position. Let's check the position between 57 and 61. Here we find the word about. As a final example, Let's look at the str_split function. str_split splits the longer string into a list of substrings based on the separator. If we use the space as a separator, or blank space, we get the individual words in the form of a list. Finally, let's unlist this and remove all punctuation. There are many more functions in the Stringr package that we haven't had time to cover in this video, but I'll leave some links down below that I encourage you to explore on your own. And I hope this tutorial has given you a good introduction into regular expressions in R and how to use them together with the Stringr package. Thank you for watching.